Right, hello everyone. Let's take a look at problem 3 in problem set 616. In this problem, they give you the uniform distributions. And the context for this problem is that when you arrive at the red line, the maximum waiting time is 60 minutes. And in part A, they want you to calculate the probability of the waiting time is at least 40 minutes. So that is the probability of, let's say, t is the continuous random variable, t is greater than or equal to 40. But the maximum waiting time for the red line is just 60 minutes. So you can rewrite this probability as the probability of 40 less than or equal to t less than or equal to 60. And this is equal to the definite integral from 40 to 60 of the probability density functions. So the job now is to identify the probability density function. And you know this is the uniform distributions. So f of t is equal to, this the piecewise functions is equal to 1 over b minus a when t is between a and b and 0 otherwise. You have to be careful here when you read the problem. You have to be able to identify A and B. In this case, A and B is not 40 to 60, right? A and B is actually from 0 to 60. So this is equal to 1 over 60 minus 0 when t is between 0 and 60 and 0 otherwise. All this is equal to 1 over 60 when t is between 0 and 60 and 0 otherwise. So the probability density function in this case is 1 over 60. Right? And go back here and we calculate the definite integral from 40 to 60 of the probability density function. That is the integral from 40 to 60 of 1 over 60 dt, and if you use the calculator, the option math 9, you can get the answer very easily. This is going to be 1 over 3 or 0.0333. Okay, so now let's move on to part B. In part B, they ask you to calculate the probability that the car waits less than 15 seconds at the red line. So that is the probability of t less than 15. But the lowest time that you can have is t equal to 0. Right? Let's take a look at this probability density function is equal to 1 over 60 when t is between 0 and 60. When t is less than 0, we don't consider that because let's assume that you don't arrive from the previous red line. Right? So that is, you can rewrite this probability as probability between 0 and 15. So this is equal to the integral from 0 to 15 of the probability density function, or the integral from 0 to 15 of 1 over 60 dt. And once again, if you use the calculator, you'll be able to get this as 1 over 4 or 0.25 for the probability. So this is problem 3. Please let me know if you have any questions.